Okay, so as promised, multiple masses on inclined planes. All right, so in this particular example, I have mass 1, which is 50 kilograms, sitting on the incline, and mass 2, which is 35 kilograms, hanging out over the edge, off the top edge, okay? Coefficient of friction of the incline is 0.15. The incline is angled at 60 degrees. Now, I'm going to have to tell you which way this is moving because it's not really going to be clear. It's not like when it's a flat surface, right? So FG2 will pull down this way, but we have an FG1X going down the incline. And which way it moves depends on like how big these two are, which is going to depend on the slope of the incline and of course friction as well. So most of the times, unless I purposely want you to figure out which way it's going to move, I will tell you. So I'm going to tell you that this one moves down the incline. So if it's moving down the incline, then it means friction on this box 1 is moving up the incline. Okay, so like I said, most times I will need to tell you which way it's moving. So it's moving down the incline, and the question is, what is the acceleration? Okay, now it becomes maybe more important or maybe more helpful to draw our boxes in a line now. So pulling back this way will be FG2 and friction on number 1. And pulling forward will be just FG1X. Okay, so we do our sum of the forces is equal to M total A. And notice I'm not calling it X and Y because really it's moving in a straight line. It's just a minor technicality that there's an incline there. And this way is, I told you down the incline, this way is positive. So FG1X minus FG2 minus friction on number 1 is equal to M1 plus M2 times A. So we're solving for A. So FG1X, if you remember in inclines, this will be M1G sine theta minus FG2X is M2G, and friction on number 1 is dependent on Fn on 1, which is dependent on FG1Y, so friction is going to be mu M1G cos theta. And now you understand why I wanted to make sure you were good with inclines before we put multiple masses on there. And then this is going to be divided by M1 plus M2. So really, it's just exactly like a sum of the forces question, right? There's nothing more complicated. You just have to divide up your forces and figure out which way is it moving. So M1 was 50 kilograms times 9.81 meters per second squared times the sine of 60 minus M2 was 35 kilograms times 9.81 meters per second squared minus 0.15 times 50 times 9.81 meters per second squared times the cos of 60, and the whole kit and caboodle gets divided by 50 kilograms plus 35 kilograms, right? So really, not bad at all. And when you do this, you should get an A, assuming you can type all that in your calculator correctly, 5253 meters per second squared. Okay? So the trick is pay attention to which way it's moving. Just solve for your forces, sum of the forces. All right, just in case, let's do an example 2. So example 2, now our incline's only angled at 30 degrees. Our mass 2 is 18 kilograms. It's accelerating 3.946 up the incline. So this time the system's moving this way. All right, so FG2 will be going down. On the back, this will be FG1X. If it's moving up the incline, friction will be moving this way. This will be your Fn, so you can balance out with your FG1Y. And this time the question is, what's M1? What's the mass of the block on the incline? Okay, so why don't you turn me off, try to solve it, and then turn me back on. Okay, I'll wait for you. All right, hopefully you're back. Sum of the forces is equal to M total A. Hopefully you were successful. So, I didn't draw my straight line, but if I did, this time pulling this way is FG2, and pulling back will be friction on 1 and FG1X, and this way is positive. So it'll be FG2 minus FG1X minus friction will equal M1 plus M2 times A. So M2G minus M1GX, again, is sine theta, minus friction, which is mu M1G cos theta. Over here you have to multiply through M1A plus M2A. Why? Because you're solving for M1. So take all the terms with M1 to one side. I'd bring them over to the right-hand side so that they're all positive. So M2G minus M2A equals M1A plus M1G sine theta plus mu M1G cos theta. Factor out the M1. So you'll have A plus G sine theta plus mu G cos theta in your brackets. And now divide by the bracket. So M1 equals M2G minus M2A over A plus G sine theta plus mu G cos theta. And fill in your numbers. I forget what M2 was, 18 kilograms times 9.81 meters per second squared minus 18 kilograms times 3.946 meters per second squared divided by 3.946 meters per second squared plus 9.81 meters per second squared sine of 30 plus, I forget, 0.2 times, 2 times 9.81 meters per second squared cos of 30. Carefully punch all of this into your calculator and you should get 9.9981. I was aiming for 10 kilograms. Okay? Hopefully that worked for you. So now you have some to do for me. So check the sheet and the teams to find out what ones I want you to do.